Hello. Can everyone hear me? Hello. Let's quickly check on the app. Um, I guess that's working, or at least I hope. Alrighty. Since we're a little overdue, let's begin. So, welcome everybody that has already joined. Today, we are talking about the first steps in becoming a test automation engineer with the Go Bigger expert Daniel. That's me. Right. So today, I'm talking a lot about my personal experiences and also some sort of pathway that you can take yourself when you try to become a test automation engineer. So, what is this webinar? First of all, we have the overview of the job test automation engineer and suggestions of things to learn and work towards. Right? And at the end, I will give you a sample pathway to become a test automation engineer. Everything is based on my own experience, and it's not always the same for everyone else. Just as a heads up, I will 100% exclude the ISTQB terminology and whatnot, so you can have a clear mind about what you actually do and not what the regularities are. Right. So let's go to the definition and the role. So what is test automation? Let's clear that up first. When we're talking about test automation, we are talking about the automated execution of test cases and comparison of actual outcomes against expected results without manual intervention. So basically, you define your script and just run it over and over and over again. If you compare it to manual testing, where you have to do it each and every time you run it, that's completely like done automatically. Let's call it that. Basically, a robot doing it for you. So, and who is a test automation engineer in this case? Well, we are talking about a person in this case, a specialist who designs, develops, maintains automated test scripts. We are talking about the scripts, right? And frameworks to ensure the software quality. Basically, a guy that is also a programmer that writes scripts and defines the framework that we're using to do the manual testing instead of by hand, just writing the script once and actually let it run, probably through a CI/CD pipeline, so you don't have to do it manually, just starting manually. Right. So why focus on test automation? Easily. It shrinks the feedback loops. What does that mean? It catches regressions quickly. You don't have to do it manually. You can do nightly runs, right? Everything can be done automatically. There's no person per se involved. It improves your test coverage and consistency. Talking about consistency, if you write your script correctly and stick to the requirements that it checks out, you will get the results most of the time exactly the same. At least in theory, let's be honest. Some scripts will not work as intended 100% of the time, but that's what you do as a test automation engineer. You write stuff, you fix stuff, and let it run, run, and run, and run. And basically, at the end of the day, have your tests automated in a, let's hope, perfect kind of way. It frees up QA teams. What does that mean? You can focus more on the exploratory testing and more complex testing, at least in terms of the manual testers, right? You are basically the middleman between the programmers or developers and the manual testers. So you give them a lot more breathing room when you do your automated scripts. Both ways, the developers as well as the manual QA teams. A critical skill in agile and DevOps environments. What do you think about that? In an agile and DevOps environment, agile way, the test automation is critical. Why? Because if you do it manually all the time, you cannot rely on your CI/CD pipelines. In an agile way, you can do the test automation dependent on the development team. You can do it in line with them instead of having to rely on them finishing their stuff first. You can interact with them in the kind of way. So building bridges basically. Right. So let's continue with the fundamentals of the software development. What do you think when you're talking about software development and test automation? You have to get your programming basics, like, for example, variables, control flows, for example, like if else statements and loops and whatnot, data structures, for example, like arrays and lists and dictionaries, as well as functions or methods, classes, and talking about classes, object-oriented principles. Right. So what you also have to know about is version control systems. At least nowadays, you should be familiar a little bit with Git, like cloning your repositories, branching, committing, pushing, and whatnot. But I will go into more detail as we go on. Basic CI/CD concepts. You've probably had some contact points with it, even without knowing it. What are we talking about? We're talking about continuous integration and continuous delivery. Continuous integration, you can think of you push your developed test automation to the repository you're in, and for example, a software like Jenkins or your GitHub Actions, if you're using GitHub, does something for you in that. As well as continuous delivery, which basically then pushes the stuff to the place it belongs to and sets it up for you, delivers it to the place it's going to be at the end of the day. Software testing basics. What do we think about that? We are talking about manual versus automated testing, right? So at least in this short webinar, I expect you to have at least a little bit knowledge about software testing, where you're basically a manual tester at this very moment and think about becoming a test automation engineer, or if you, for example, have been a developer before, that you want to become a test automation engineer, which basically every developer can become a test automation engineer very easily, because at the end of the day, they're doing the same, just with a different approach, right? As well as you should have some familiarity, right? My English is not the best today, I think. So some familiarity with the different testing levels, right? We are talking about unit tests, integration tests, functional tests, end-to-end tests, and whatnot, or, for example, smoke, regression, performance, and security tests, which I will cover later on. Right. So the fundamental tools that you should be familiar with as a test automation engineer. For example, an IDE, integrated development environment, or a code editor for short. For example, if you are in a Java environment, you use IntelliJ. If you're with whatever programming language you like, you could use VS Code, for example. Or if you're in a Python environment, you could use PyCharm, depending on the different languages that you use for your test automation. But, a little but, you don't necessarily need to program manually. There are also tools that basically have a little bit of code or no code at all, basically capture and replay functionality, but we don't talk about that today. We talk specifically about the test automation engineers that actually code at the end of the day. So a little bit of familiarity with build tools. For example, when we are talking about Java, we are talking about something like Maven or Gradle. If we are in a JavaScript or TypeScript environment, we are talking about NPM. Or if we are in a Python environment, we are maybe talking about pip, poultry, and whatnot. There are so many different build tools. I cannot cover them all today since we are a little short on time. But yeah, that's what you have to look out for at the end of the day, since those are going to be your best friends. What I would suggest, you should have at least some command line proficiency. What does that mean? You should at least be able to navigate through folder structures, run scripts over the command lines or pass logs, and just basic stuff that you can do in the command line in Linux, in Mac OS, in Windows, and whatnot. Just be a little bit on the nimble side of things, talking about the command line. What kind of mindsets and soft skills should you bring into the round if you want to become a test automation engineer? You should have a good attention to detail. You have to spot edge cases, cover flaky tests, and subtle UI difference. So that's also what you should bring in if you want to become a manual tester, but even more so if you want to become a test automation engineer. Analytical thinking, what does that mean? You have to design the test scenarios that cover both the so-called happy path as well as negative conditions, right? So not just being a code monkey, just type everything in and we are happy and done for it with the day. You always have to think about the negative conditions as well as the happy path. In the olden days, when I was a young test automation engineer, I was always focusing on the happy path and left out the negative testing. So those were times that did not end so well. I had to redo much of my script, and that's what I want you to not experience as well. So listen to me. Right. Collaboration and communication. Since you're building bridges between the developers and the manual testers, your communication skills have to be on point, basically. You are also talking, most of the time at least, to the requirements engineers that provide you with the requirements that you are automating and testing. So, yeah, get ready to have a lot of collaboration meetings to do refinements and whatnot, at least in the agile way, which we at least expect you to have some sort of knowledge by now. Persistence and patience. To be honest, tests frequently break, and you have to withstand the stress that is attached to that. You have to diagnose the failures that can be time consuming and whatnot. Sometimes the developers blame you if you find bugs in the software. You have to be very hardened if you try to approach the test automation engineer job. It's not always easy. So, sometimes it could be easy if the software developers are experienced enough that they produce not bug-free, but at least bug minimal software that you are not always needed to be on the very edge. Right. So that's what the mindset and soft skills are needed, right? Now we're talking about the programming and scripting skills. You should have at least some of those. Right. Choose a language commonly used in test automation. That is just a thing that you have always to keep in mind. The test automation engineering area is very competitive by now. So choose a language that is used often. so you land the job easier, right? I speak from experience. Even though I have years and years of experience, there is always at least some guy that is more proficient in a very specific language. So, yes, you can always invest time and, in this case, also money into different, let's call it exotic programming languages. But at least in my opinion, stick to one thing that is broadly used, become efficient in it and proficient in this case, and find your own market, right? You could always go the route with the lesser used programming language, but don't expect to be needed that much in this competitive area. Right. Some key techniques that you need to have as a test automation engineer. For example, when we are talking about UI testing, you should be able to locate elements in a UI. You should make HTTP requests and at least some sort of API testing skills. What you should always consider is data-driven testing. What does that mean? Instead of hard coding each and every value, you provide the test automation environment that you created with at least some CSV file, some JSON file, XML file, at least some sort of data structure that you can feed into your test automation, and just give it this, for example, a table, and let it iterate through each and every line that you provided instead of having to write the same script 10 times with different variables in it. Right. So coming to the testing frameworks and libraries, which I would suggest you have a look at. For example, if you're on the more developer-friendly side of things, unit testing frameworks. For example, if you are in a Java environment, JUnit or TestNG could be a candidate for you. If you are in a Python environment, maybe go with PyTest or UnitTest. Or if you are in a JavaScript or TypeScript environment, maybe try Jest or Mocha. When we are talking about end-to-end tests, for example, or UI automation tests, then I could suggest to you maybe the Selenium WebDriver, which is very popular in web testing. If you are proficient in JavaScript or TypeScript, maybe try out Cypress or Playwright. Or if you are once again on the more adventurous side of things, maybe try out Appium, which is basically a tool for test automation on iOS and Android. Maybe that's your thing. Right. Then we come to the API automation tools. For example, once again, with different languages in mind. For example, Java, you could use REST Assured. If you are using Python, there is no real library, not an explicit tool. You just use the request library and PyTest. Or if you're using JavaScript, maybe you could use Postman or the Newman CLI. And drifting apart a little bit from the frameworks, from tools, talking about frameworks a little bit. Maybe you've heard about the behavior-driven development, or BDD for short, where you basically specify what the software should do instead of what you want it to do, right? There you can use Cucumber, for example, with the scripting language Gherkin, or at least in the Java or JavaScript environment. Or if you use Python, you could use Behave. So I have one tool for you that basically could do everything I told you before in one bigger package, which I endorse as well as use basically every day in my job. And it's called the Robot Framework. Maybe you've heard of it before. At least in my opinion, that's a good starting point for everyone that has no idea yet where to start. But just give it a try. Give everything a try if you have no clue what to do. We go over a sample path later on, but that's what I would recommend, at least by heart. Right. So test design and best practices. From my point of view, the test pyramids basically is the perfect starting point to think about. Many unit tests, um, a little bit on the integration test side, and even less end-to-end tests. So think about it as the pyramid you see already describes. The foundation is the unit tests, and towards the top, you need less and less of it. So give it a good foundation, and the more to top you go, the less you need. If we are talking about UI tests, I would suggest go with the page object model. What does it describe? Instead of hard coding each and every thing manually for each and every step, we think about the page, the web page, as an object, if you are thinking in object-oriented kind of way. For example, we have the Google website. That could be the class Google. And then the logo could be an element inside this class or the search bar. And we're basically mapping it for this class. And then later on in the automation script, we can always call the different parts of the website by naming it, right? We then just say we need a new Google object. And from the Google object, we want to interact with the logo or with the search bar and whatnot. And that's a really efficient kind of way to model out everything you have on a website. Give it a try if you have not done it before. Right. Talking about assertions and reporting. Assertions is when you basically refer to the wanted outcome to the actual outcome. Use expressive assertions. They should speak for themselves. Just saying true equals true does not help anyone. Um, think about it like have your expected value as this is the expected value and say it should equal to the actual value. Give it names that speak for themselves. Talking about reporting, generate clear machine readable reports. For example, which are some stuff that I've used before, Allure or extend reports in the Java environment, for example. By the way, Robot Framework itself provides clear and machine readable reports as well by itself. You don't necessarily have to refer to third-party libraries. So always keep that in mind. Right, parallelization and scalability. That's more of the advanced stuff, but I want to at least tell you a little bit about it. Configure parallel test execution. What does that mean? Sometimes you have the situation where you can run 2 tests or even 3 tests or 4 tests or whatever kind of number you can imagine at the same time to save some time, right? That's basically every time you don't change any data, you just maybe retrieve some data, then you can use parallel execution. For example, TestNG, PyTest, XDist, or just watch provides that functionality. If you're writing data and you have tests that refer to the same data, don't try to do that. Use CI/CD pipelines to spin up containers in Docker, for example, or leverage cloud grids, for example, Browser Stack or Source Labs. In that kind of way, you have the scalability aspect. You could always go broader if you need more calculation power for that. That's more of an advanced topic. Right, some common pitfalls that you might encounter if you're trying to become a test automation engineer. Lack of a stable test environment. What does that mean? Yeah, sometimes you have frequent database resets or competing data. What does that mean? Sometimes you set value A and then read it in another test, but it was set by the prior test. So yeah, what can we do about that? Always reset your test environment after a test. So if you set data, reset it at the end. right? Or if you log in into something, log out at the very end. You could also have some unpredictable third-party dependencies. Maybe the APIs that you're referring to are not always online, so could always be a challenge. So stick to the stuff that works. Fully designed test architecture. What is that? Sometimes, if we are talking about UI tests, um, people tend to hard code the locators, for example, the XPath and whatnot. And that could be fragile. What does that mean? Even the smallest change in the UI could break the automation. So it's very hard to maintain. So always watch out for that. Flaky tests. What could that mean? Flaky tests are something when you run a test and sometimes it works and sometimes it does not. My machine is about to shut down, I think. I try my best to stay online. Um, right. If you don't have the possibility to run your test every time and it has the expected outcome all the time, we're talking about a flaky test. Could be some timing issues, some order dependence, or sometimes race conditions and whatnot. So always watch out for your flaky tests. Make sure your tests run the same all the time. Right, some other common pitfalls. Over-testing or duplication. Sometimes it happens that you take over the test automation stuff from a colleague, for example, and then you try to re-implement stuff that has already been done. Always look at the code that has been done prior to you doing stuff or even your own, and don't duplicate it. Try to refer to the older stuff as well. Ignorant maintenance cost. That's a huge pitfall that many people tend to fall into. Test automation is cool and all. So are we still online? Right now my camera seems kind of frozen. Uh, well, then I think I have to continue on without the camera. Right, where were we? Right. Can you hear me? Am I back? All right, cool stuff. Right, then let's continue on. Sorry for the little interruption. My machine wanted to go offline for whatever reason. Right, talking about maintenance cost. Right. Test automation is fine and dandy, right? But um, at the very end of the day, sometimes there are changes to the software, and the test automation scripts have to be maintained somehow because they are not going to run forever by themselves. Maybe the requirements change, or maybe the software itself, or maybe also the software that we're using for our test automation that has to be maintained somehow, right? So that has also a cost attached to it. That has not to be ignored in this case. Lack of reporting and visibility. What does that refer to? Yeah, tests are run locally and are not integrated into the CI/CD pipeline. What does that result in? Yeah, you have your reports on your own machine, but not in a way that other people can access it. You need a centralized dashboard or, for example, email notifications when a test breaks. So if something goes wrong, you can always refer to it in the dashboard that everyone can access it. Skipping soft skills and collaboration. Most of the time, manual testers or test engineers work in isolation and don't discuss the requirements and whatnot with other people. You always have to think as a team and a whole. We are not individual fighters. Everyone should collaborate with each other, and everyone is responsible for the quality at the end of the day. So please, for the love of God, keep on talking to each other. Right. So those are the most common pitfalls. Right now, I want to show you an example pathway that you can take. I will split it up into different weak groups, so it's not too overwhelming for you. First, pick a programming language, for example, Java, Python, JavaScript, and whatnot, and stick to it, at least for those very beginnings. Learn your version control, for example, Git. Not for example, specifically do Git, because that's what everyone is using, and that's state-of-the-art technology, and it's not going to change anytime soon. Please don't use something like SVN, Subversion, because that's way too outdated. Stick to Git. Understand manual testing concepts. So if you have not been a test automation engineer before, read the syllabus of the ISTQB, for example, get to know at least the basic concepts of manual testing before you start to implement your automated tests. You could do it like hand in hand, but try to do one thing at a time at this very point. After that, we come to weeks 5 to 8. Try out some unit testing frameworks. We've talked about them before. If you've been a developer before, you should be familiar with them at the very least. They are always dependent on the programming language that you use. Try out some simple API testing. Download, for example, Postman and try out some public APIs that you could test, right? So you get at least some familiarity with it. I know we're talking about 4 weeks, but that's going to take some time to get familiar with everything. Speaking of weeks 9 to 16, I know that's a little bit of a broad week spectrum, but watch out. For example, the Selenium WebDriver or Cypress and Playwright. In this case, we are talking about web UI automation. That's always a go-to because the results are visible, very easy, and you could basically automate anything. For myself, I tried out Google at the very beginning. That's what you can do as well. We were talking about the page object model. You could basically create a page object model for the Google website. Talking about we have the class Google, and it has the different attributes of the logo, the search bar, and whatnot. Everything modeled out. If you have done that, maybe try out data-driven testing so that you create different tables in CSV, not Excel, that's not always supported, but try out different things and try a data-driven approach to it instead of manually hard coding every single tiny part. Reporting and logs. Get familiar with good reports. Try to log out the different things that you do instead of letting the software handle it itself. Yes, for example, Robot Framework does an excellent job with it, but at least try to get familiar with good logging so you know at what point something could have been broken if something breaks. Right. Speaking about weeks 17 to 20, learn a CI tool. What does that mean? Yeah, we're talking about CI/CD pipelines. Get familiar with, for example, GitHub. It's free. Let your test automation run through the CI pipeline. Maybe create some sort of quality gate. Different stuff with the online tools that get provided for free. Or, for example, what you could also do, Azure DevOps. There is a free version of it. Give it a try. Parallel execution and containerization. Yeah, that's very advanced. If you are familiar with the CI tooling, try the parallel execution, for example. Maybe try to run 2 Google tests at the very same time and look what's happening. That's like only 20 weeks, but by then you should at least be familiar with the different technologies and different techniques that test automation could provide to your potential clients. From that on, I will give you some learning tips that you could apply to that very same thing. Set small, achievable goals. Don't try to rush things. Everything comes by the time you actually do it. Don't get threatened by people that maybe learn faster than you. If you keep on sticking to it, you will achieve your goals, but try to chop it up into smaller chunks so you don't get overwhelmed. Build a portfolio. For example, as I told you before, GitHub is a great starting point. You could always open source the stuff that you do, so potential clients could have a look at your account and you have something to present at the very end, right? Because people sometimes, let's be honest, talk out of their ass. And if you can provide actual proof that you are capable of doing things, that's always a huge plus in this competitive field. Network and engage with communities. That's always, always a thing. You have to network in these times. For example, go to LinkedIn. Maybe join the community Slack of Robot Framework, for example. Maybe try to interact with the different repositories of open source solutions. Provide them with some bug reports, or maybe try to implement stuff yourself and provide a pull request for them. Don't underestimate the open source communities. Everyone knows each other, even one step or two step or three steps above or below. Try to interact with people. We are one community at the very end. Focus on test design and strategy, not just scripting. That's easier said than done. I know that. People want to get stuff done, like start scripting immediately, but take your time, design everything well first, set the foundation correctly, and then go over to scripting. Keep that in mind, always. The very conclusion, I know I took a little bit longer, but sorry, my machine went off for whatever reason. The conclusion, even though we are thinking in sprints, talking about agile, becoming a test automation engineer is a marathon, not a sprint. Wink, wink. So that's the end of the presentation itself. I want to cross over the current offerings that we provide. What would be a huge plus that you would follow us on LinkedIn, where you probably heard of us before, and that would be a huge win for us if you could leave us a like or a follow, a comment on the YouTube video and whatnot. Always appreciate it. You can check out our courses and our workshops. We have them provided for you under the URL https://go-bigger.de/shop. I will provide you with the links in the caption once everything is recorded. There you could find our, for example, our Udemy course and our upcoming courses about the ISTQB foundation level, for example, or for the Robot Framework RFCP, Robot Framework Certified Professional, pre-training for the exam, for example, or what you can always do, subscribe to our monthly newsletter, Grow Bigger. Let it be known, we are only doing this once per month. You will not get spammed if you want the newsletter. You could always subscribe to it. I think the last one was sent out a few days ago, so the next one is going to be at the start of next month. Right, so that's it. The first steps in becoming a test automation engineer. I hope you enjoyed. You learned a thing or two. And next week, the topic will be using dev containers. If you are interested in that, I think we already set up an event in LinkedIn. You could always join that and you will find the URL there. And if not, you can search for the link in YouTube itself. And if you're subscribed to us on YouTube, you will get notified that we are doing it the same time. I think 12:30 GMT +2 on next Wednesday. My name is Daniel from Go Bigger, and I wish you all a nice day. Take care.